What would happen if humans planted 1,000 trees on Mars? And 1,000 people tried to live there for an entire year. How many days would they even survive? Mars sits 225 million kilometers from Earth on average, a trip that takes 6 to 9 months even with our fastest rockets. Its atmosphere is 95% carbon dioxide. The average surface temperature is a brutal negative 63 degrees Celsius. Humans cannot breathe there without full life support systems. And the sunlight? Only about 43% as strong as back home on Earth. One single failure, and this whole experiment could be over in days. So let's run the experiment, right here, right now. Could these trees survive on the open Martian surface? Not a chance. The air pressure is so low that your own blood would boil. Nights plummet below negative 100 Celsius, freezing anything solid. Toxic perchlorate salts in the soil act like poison. And without a magnetic field or thick atmosphere, solar radiation and cosmic rays would shred DNA in minutes. But inside sealed, pressurized greenhouses with Earth-like air, perfect temperature control, UV shielding, and cleaned-up soil. Absolutely. A mature tree produces roughly 50 to 100 kilograms of oxygen per year through photosynthesis. 1,000 trees? That's 50,000 to 100,000 kilograms of fresh oxygen every year, enough to help sustain hundreds of people if the system recycles perfectly. Would they change the whole planet? No way. Mars' entire atmosphere weighs about 25 trillion tons. These trees would barely make a dent. But they could be the first green heartbeat on a dead world, the first real proof that Earth life can take root here and start making Mars just a little more like home. Now imagine scaling it up. 1,000 humans trying to last a full 365 days. Each person needs about 0.84 kilograms of oxygen every single day. For the whole group, that's over 300,000 kilograms in 1 year. Food? Roughly 1 kilogram of calories per person daily. More than 365 tons total unless they grow it themselves in those greenhouses. Water? 3 to 4 liters per person for drinking, cooking, and hygiene. With 95% recycling, they could stretch what they mine from vast subsurface ice deposits. Homes would be pressurized domes on the surface or lava tube bunkers dug deep underground for natural radiation shielding. Gravity here is only 38% of Earth's. You can walk, but your bones and muscles start wasting away without 2 hours of daily exercise in spinning centrifuges. Daily life looks like this. Sunrise workouts, hydroponic salads for lunch, evenings monitoring air recyclers while dust storms rage outside. Families share stories under artificial stars projected on the ceiling just to feel normal. It would be the ultimate test of human grit. Because the problems don't mess around. No breathable air, one tiny leak and you're gone in minutes. Extreme cold that sucks power from every battery. Radiation levels 240 to 300 millisieverts per year. Over 100 times what we get on Earth, quietly raising cancer risks with every passing day. Dust storms that can blanket the entire planet for weeks, killing solar power and coating everything in fine, choking grit. Water locked deep in ice, laced with chemicals that corrode equipment and harm the body. The psychological toll of being 225 million kilometers from everyone you love, months away from any rescue. One heart attack, one failed pump, and the whole colony could be counting its last days. But here's the good news, we're not helpless. The solutions are already in our toolkit. Massive greenhouses packed with trees and crops under full-spectrum LED suns. Underground cities or giant transparent domes for radiation protection. Solar farms backed up by small nuclear reactors that keep humming straight through the longest storms. Robots melting Martian ice and purifying it for drinking and fuel. Electrolysis splitting water into oxygen you can breathe and hydrogen you can burn. Advanced recycling systems that turn sweat, urine, and exhaled CO2 back into clean water, air, and even fertilizer at 95% efficiency. NASA, SpaceX, and private teams are testing every single piece of this right now in labs and on the surface. Could Mars eventually support a permanent human civilization? It could start in decades with small, self-sustaining outposts. Full terraforming, thickening the atmosphere so we can walk outside without a suit. Might take centuries of breakthroughs in artificial gravity, massive orbital mirrors, and bioengineered microbes that actually change the air. But it all begins with 1,000 trees and 1,000 people willing to bet their lives on the red planet. The camera lingers on a single sapling inside a glowing dome, Leaves swaying gently in recycled air. If humanity succeeds in turning Mars into a living world, could it become our second home, or will Mars always remain a cold and hostile planet? A long, contemplative beat. The sun crests Olympus Mons, painting the dunes blood red and gold.